This is the final video for the review of the Unit 1 test, the practice exam number 1 from BVD4e, page 177 through 147 to 149, pardon me. Here we're looking at the free response questions. Free response. Okay. We have some summary statistics for daily high temperatures from June to November in Champaign, Illinois. Based on these statistics, what do you suspect to be true about the shape of a distribution? Well, we have Q1, Q3, min, max, and median. What we have here is a box plot, but we also have the mean. So we can compare the mean with the median. And from earlier, if you recall, if we have a distribution that is right skewed, when it's right skewed, typically we're going to have a mean that's further towards the tail. The outliers pull the mean, and as we move to the right, we're greater. So when we're right skewed, we're going to get a mean that is greater than the median. However, when we are left skewed, it's going to be the opposite. All right. If we're left skewed, the outliers are over here. They're going to pull the mean in that direction. So now the mean is going to be further to the left. Thus, the mean is less than median. Now, it's not always the case moving in this other direction. Just because the mean is less than median, we can't automatically say that it's left skewed, but perhaps we can, if we're going to say in one direction or the other, we'll say that. So in this case, I can see that the mean is 75.8 and the median is 79. So the mean is less than the median. Since the mean is less than the median, very likely we're left skewed. Based on the statistics, what do you suspect to be true? All right, we're not certain, but if we're going to be shooting one way or the other, since the mean is less than the median, I'm left skewed. Since the mean is less than the median, I suspect left skew. Okay. B, are there any outliers among these temperatures? Well, you may remember our outlier rule. We know that it's an outlier if we are greater than 1.5 IQR above Q3 or less than 1.5 IQR below Q1. All right, so we have Q3 that is 89, Q1 that is 63. Thus, our IQR is the difference there. 89 minus 63, our IQR is 26. All right, so 1.5 IQR, 1.5 times that number would be 39. So I want to look at Q3 plus that 39. Q3 plus 39. That is 89 plus 39. That's 128. Okay. And then let's look at Q1 less 39. That's 63 minus 39. I believe that's 24. So these are the boundaries of my outliers. Anything within that we will consider not outliers. If you're beyond that, we will consider them outliers. So looking back, our min was 31 and our max was 101. Alright, so our min and our max are within those bounds, thus we have no outliers. B, since 31 and 101 are within our 1.5 IQR boundary, and that boundary is from 24 to 128, there are no outliers. Alright, that is B. C says, below is a box plot for December through January. Sketch a box plot of our data on the same axes, above it on the same axis. So going back to the picture, see if we can increase the size of our picture, and I'm going to make a new box plot. Well, min is 31, so if that's 20, that's 30. 31 would be right about there. Put a point there. Q1 is 63. If that's 60 and that's 80, 63 would be about right there. That's Q1. Median is 79. That would be just a touch less than 80. Right there. Q3 is 89. If that's 80 and that's 100, 89 would be right in between, about right there. And max is 101. A little bit more than that. We know there are no outliers. So here is the IQR portion, the actual box. Here's our median. Alright. And there's our max. There's our min. And here are our parallel box plots. Alright, that is C. Okay. D, write a few sentences comparing these two distributions. So I want to compare these two. Alright. Distributions. So remember, when we're comparing one variable distributions, we will employ SOX. Shape, outliers, center, and spread. Okay. So to begin with, shape. Well, first of all, although a box plot is not the tool to consider shape, this distribution looks fairly symmetric, and we've already stated that this one's left skewed. Okay, so I'm going to call this one plot 1, and let's call this one plot 2. Okay. So the box plot for plot 1 is approximately symmetric, while the box plot for plot 2 could indicate left skew, because as we stated previously, the well, we don't know from the box plot that the mean is less than the median, but we know by the statement of the data. Okay. So plot 1, fairly symmetric. Plot 2, potentially left skew. All right. Outliers. Neither distribution has outliers, and in that case, I'm not even going to necessarily mention that. Shape, center, and spread are the big ones. Center. Plot 2 has a higher median than plot 1. So let's indicate actually what we're talking about in this case. Plot 2 is our June to November. June to November has a higher median daily high temp than December to May. And spread, it looks like they have similar, my IQR here is about 40 to 42 to 78 or so, and my IQR here is about 60 to 100. So they have similar spreads by IQR, and they have similar spreads by range. Both IQR and range are fairly similar. All right, so we have compared the shape, the center, and the spread for those two distributions. Okay. Number 2. I'm going to look at my first question sentence using the 68, 95, 99.7 rule. So we know we're talking about the empirical rule. A normal model we're dealing with. Sketch the appropriate model. 40 and a standard deviation of 4. So we are normally distributed with a mean of 140 and a standard deviation of 4. Let's draw that normal curve. Mean of 140 and a standard deviation of 4. So this is 144, 148, one more, 152. Coming down, 140 minus 4 is 136, 132, and 128. All right, this is our normal model. What are we talking about here? It says we are talking about the useful power for some particular brand of battery. So 140 hours with a standard deviation of 4. So 68% of our batteries will fall from 136 to 144, 95 from 132 to 148, and 99.7 from 128 to 152. This is A part. A. B. The marketing department wants to write a guarantee for battery life. What lifespan would they quote so they can expect 98% of the batteries to meet the guarantee? All right. We want 98%. Okay. Well, our 68, 95, 99.7, we would get 95 from 132 to 148 and 99.7 from 128 to 152. So we know it's going to be somewhere in here. Okay, we would expect 98%. Well, if we got 98%, my question is, what area would be out here and what area would be out here? Well, we would expect 0.01 out here and another 0.01 out here. If we knock off 1% on each side, we would get 98% in the middle. Well, now we can consider our percentiles. So this here would be the first percentile, 1 percentile. and this here would be the 99th percentile. So we want to find what those observations are going to be. So to find this, what the first percentile is, I'm going to use my calculator and go inverse norm. I want the first percentile with a mean of 140 and a standard deviation of 4. I expect that's going to return a number very close to 128, but slightly larger than 130.7. That's that low bound, and that makes sense. It's slightly more than 128. It's like 2.7 above that. So we should have the same thing here, 2.7 below. This is going to be like 149.7. So if I do inverse norm of 0.99, 144, I get 149.3 as we anticipated. Alright, so if we're somewhere between these values, we would capture 98%. So we probably aren't going to report 130.7 and 149.3. So perhaps if I'm quoting, I would say, so quoting 130 to 149 hours would capture 98% of batteries. Alright, that's B. C. Get to the question sentence first. What other improvement must they make to achieve their goal? The company's research department has been given the task of improving the batteries with a goal that at least 90% of new batteries should last longer than the average of the current type. Initial research suggests that a mean of 143 is attainable. What other improvement must they make to achieve their goal? Well, we've improved the mean. Okay, that is, we have shifted the distribution over. So our new mean, our new model, let's say our normal model new for our improved battery, okay, has a mean of 143. Well, what we need to do here is we need to change our standard deviation some which how. What do we want to do? Well, we want to tighten up the standard deviation. That is, if the batteries, if their performance was less variable, we would be guaranteed to have superior battery life. So we would hope to decrease the standard deviation. We should decrease the standard deviation. That is, our batteries need to perform more consistently. Okay. Specifically, what value do we need for it to be such that 90% of our batteries are, it says 90% of the new batteries should last longer than the average of the current type. Alright, so we want 90% to be greater than 140. Well, with our current standard deviation, if we we know we should decrease the standard deviation. We know we need to do that. But the question is, how much do we need to decrease it? Well, let's draw a new normal curve. Our new normal curve is centered at 143. That's what we're saying. All right. It says that there's a new mean of 143. But the question is, how much do we need to make this standard deviation in order for us to get this new improvement? That is, we want 90% of our stuff to be above 140. So we want to place this 140 in such a place that 90% is to the right. Said another way, we want 10% to the left. Well, we know here is the 16th percentile, so it's going to be somewhere in here. Here's what we're saying. We want this x to be 140, and this x is placed in such a way that the area down here, this area, we want this area to be 0.10. All right? We want it to be 0.10, not even about, but we want this to be 0.10. So, said another way, we want 140 to be at the 10th percentile. 10th percentile. All right. So, what we have our normal curve with a mean of 143. And some standard deviation we don't know. What standard deviation is going to allow 140 to be at that position? Well, let's go to our z formula. Z is equal to x minus mu over standard deviation. This time we know the x. All right, the x is 140. X is 140. We know the mean, it's 143. This time I'm trying to find the standard deviation. Well, we need the z-score that's associated with 10%. I can go, again, inverse norm of 0.10. All right? That's going to return my appropriate z-score. And hopefully you know it's going to be less than -1 but greater than -2. And when you do this inverse norm, you can just do inverse norm, or you can tell it you want a mean of 0 and a standard deviation of 1. This is giving us our standard normal result, and it's a -1.28. All right. So our z is a -1.28. All right. We want to solve for this sigma. We need to multiply it by it on both sides. Multiplying by sigma on both sides to get it out of this fraction. So sigma cancels with sigma to leave us 140 minus 143. That is a -3. Okay, so -1.28 times sigma, just rearrange those, is equal to -3, dividing by -1.28 on both sides. Sigma equals -3 divided by -1.28. That is, sigma is 2.34. So if we can get our standard deviation down to 2.34 combined with this improved mean, then we will have 90% of our batteries will last greater than 140. So we should decrease the standard deviation, and specifically we need to get it under this number, under 2.34. All right, last question, D. Explain what the improvement you suggest in Part C would mean about the new batteries. I think I just answered it in D and C. decreasing the standard deviation would mean that the batteries are performing more consistently. That is, their life, how long they're lasting, is less spread out, less variable. All right, and when we're making a product, that's one thing that's going to be very important to us. We want the product, we want the customer to be able to depend on the product, and in order for them to depend on it, its performance can't be very spread out. It has to hit close to the mark. All right, whatever it is that we're shooting at this 143 mean. We hope that our batteries get very, very close to that. In fact, it would be fantastic if we could tell our customer, this battery is going to last exactly this long, like it's just going to die the minute after that. Then the customer could really make plans around that and count on it. So whatever improvements we're making to the technology, I don't know what that is, but our hope is that we make the product perform more consistently. We decrease the standard deviation of the battery life. All right, with that, you should be able to grade your practice exam.